In this video, you are going to find out what a horizontal asymptote of a function is, what it tells you about the function, and you will learn some Greek on the side. When investigating a function y is equal to f of x, it is interesting to see what happens to y when the value of x becomes larger and larger. Why? You will find out later. Let's first look at the function y is equal to 2x plus 1. You know that the graph of this function is a straight line. What happens to y when x becomes really large? Let's see, do you think x is equal to 1000 is large? Then y is equal to 2000 plus 1 is also large. So in this case, the larger x is, the larger y will be, as you can see in the graph. And what if x is large on the negative side? Say x is equal to minus 1000. Then y is equal to minus 1999. Also large on the negative side. Nothing exciting going on here. Okay then. What about the parabola y is equal to x squared plus 1? When x gets large, y gets even larger. And when x becomes large at the negative side, y is large on the positive side because of the square. Now here is an interesting case. The rational function 2x squared minus 1 divided by x squared plus 1. First, let's plug in some large values of x to see what happens. If I don't have a calculator, which is the case right now, I would estimate the value of y like this. For x equal to 10, you get 200 minus 1 in the numerator on top and 100 plus 1 in the denominator, which is roughly equal to 200 divided by 100, which is equal to 2. For x is 1000, you get something like 2. And for x is 1 million, you also get 2. Now, with the calculator, you get more precise values, as you can see here. And you may observe that the value of y gets closer and closer to 2 from below. Here you can see this in the graph of f. And here is an animation to show this to you. The line where the value of y is 2 is a horizontal line at height 2. And you see that the graph of f will come closer and closer to that line. If you narrow the yellow strip more and more, you have to move to the right with your x value, but you will reach a point where the graph of f is within the yellow strip and arbitrarily close to the horizontal line y equals 2. This line is called a horizontal asymptote. Horizontal because it's parallel to the x-axis, and asymptote is a contraction of the following three Greek words. A means not, syn means together, and totos comes from falling. In modern English, not coincident. Now, is the function really never reaching the line? Let's check whether f can be equal to 2. For this we have to solve f of x is equal to 2. So then 2x squared minus 1 should be equal to 2x squared plus 2. And you get minus 1 is equal to 2, which is clearly not true. So f of x is equal to 2 cannot happen for any x. So you have seen that fx will never actually coincide with the line y is equal to 2, but it will come arbitrarily close. To denote this fact mathematically, we say that f of x approaches 2 when x tends to infinity. Or the function f has a horizontal asymptote at y is equal to 2, and you write it like this. Or the limit of x to infinity of f is equal to 2. The definition of this limit will be given in class. Here's a small practical example of a horizontal asymptote. Suppose a shop offers the following deal. You buy a product P for 5 euros. Every following product P you buy only costs 4,5 euros. As you buy more and more of the product P, what is the average price of P? Your intuition tells you it will get closer and closer to 4,5 euros, right? Now let's make this intuition precise. Suppose you buy n extra copies of the product P, then the average cost of a product P is captured by the formula average cost as a function of n is equal to 5 plus 4,5 times n divided by n plus 1. From this, you may conclude that the limit of n goes to infinity of average cost as a function of n is equal to 4.5. So y is equal to 4.5 is a horizontal asymptote. Now practice the notion of horizontal asymptote to get familiar with it yourself.